Hi, everyone. Very good afternoon. Imagine that you walk into your office tomorrow, and instead of your regular ham of activities, you found a chilling truth that your entire virtual infrastructure got locked. Not just few files, but all of them are encrypted.
Did you do the shout
The critical workloads that runs your business operations are inaccessible. The very systems that you rely on as the last line of defense, which is your backups, are encrypted. The security solutions like your EDR management servers, your backup servers, your patch management, your PAM solutions, which are all hosted in the virtual infrastructure, are compromised. Your IT team will be running in all the directions to look for a clean backup to start the restoration activity. Just imagine the efforts that your organization is going to put to bring back the business online. So this is not a hypothetical nightmare. This is the stark reality that an organization is going to face when they have a ransomware attack, as well as if their virtual infrastructure gets compromised. Thanks for joining this session, Instant Response in Virtual Infrastructure, Combating APT and eCrime Threats. I'm Thiru. I work for Mandiant Consulting, part of Google Cloud. So we predominantly support our customers to respond and remediate to major security breaches, as well as to proactively assess the security posture of their environment. Today, I'll talk a lot about bare metal hypervisors. That's a core component in a virtual environment. And we'll discuss some intricate attack techniques used by eCrime actors such as ransomware operators, as well as sophisticated techniques used by nation-state threat actors. We'll also discuss some critical steps on how to investigate and remediate these threats. Bare metal hypervisors, so they are the virtualization software that runs on top of the hardware stack. So pretty much when you want to create a virtual machines, so that's all done in the hypervisor layer. So hypervisors are always a prime target for threat actors. So mainly because a lot of organization security team, they do not monitor hypervisor logs. And not only that, some of the hypervisor softwares, they don't support antivirus or EDR solutions. Ransomware operators, previously, when they need to encrypt like 100 servers, for example, they need to laterally move into each individual servers. They need to push the binaries. They do that in an automated fashion, and they detonate it in each individual servers. But in the recent few years, they are detonating the ransomware binary in the hypervisor layers. So in a matter of few clicks, they can encrypt the fleet of VMs. So that's the main reason they're targeting hypervisors. And interestingly, we're also seeing nation-state threat actors. They're also targeting hypervisors so that they can do persistent activities in the targeted guest virtual machines. Just to brush your skills, I'm going to talk about VMware today. So VMware is one among the leading virtualization provider in the market. Right? ESXi plays the hypervisor role. That's an enterprise-class bare metal hypervisor. So that runs Unix-like operating system. Right? That's a VMware proprietary software. And ESXi don't support EDR or AV component. So pretty much for the SOC team, they have very limited visibility on what's happening in the hypervisor layer. And in larger organization, when they have multiple ESXi hosts, they need a management server, which is called as vCenter. So we'll talk about threats that are targeting VMware ecosystem today. ESXi hypervisors can be accessed through SSH, web interface, console, as well as through web API calls. Typically, we have seen threat actors accessing ESXi through SSH as well as through web API calls. A lot of organizations, they integrate ESXi with Active Directory. We don't recommend that, mainly because if an Active Directory is compromised, pretty much threat actors can easily laterally move into ESXi hypervisors. But still, there are organizations, they do that. When an ESXi is integrated with Active Directory, there's a group called ESXadmin gets created in the Active Directory. So whichever user accounts that has membership privileges over this group will have an administrative permission in the ESXi host. So when a threat actor is doing an AD reconnaissance, and if they identify this specific group, then it's a clear indicator to them that the organization has a VMware ecosystem and that is integrated with Active Directory. So I generally recommend my customers to change the default name at least, so that you can reduce the exposure of ESX administrator. All right. I'll touch base into these 4 different techniques, and a few of them are sophisticated techniques. And we'll also talk how to investigate and remediate these threats. Ransomware targeting ESXi. In a general scenario, a ransomware operator, they get an initial access, either by social engineering or by phishing, or even by compromising the edge devices. That includes your VPN gateways or Citrix gateways or Exchange cache servers. So once they get an access, they always go behind Active Directory. There are always 100 ways to compromise Active Directory. Let's not go into it. But once an AD is compromised, they laterally move into ESXi hypervisor. They move the binary, and they look for backups. Where are the backups stored? They'll try to delete it. And then they move the ransomware binary, stop the VMs, and they execute the ransomware in the hypervisor layer. So now, in a few clicks, they'll start the encryption process. So this is a modus operandi of ransomware operators, no matter what flavors they have. It can be like BlueHat or Hivelock or Lockbit or the recent one like Akira's. The modus operandi is pretty similar. Now let's talk about how to investigate this threat. I'm going to list out some of the logs in the ESXi which you can leverage for investigation as well as for the monitoring purpose. Let's go one by one. Syslog.log. So this records all the general system log messages in the ESXi hypervisor. So whoever connects the ESXi, the IP details, username details, and the file executions are recorded in this specific log file. Another log file called as auth.log. So this records if anyone tries to authenticate through SSH to the ESXi host, that will be recorded here. And then comes shell.log. That's my favorite. So any command execution that happens within the shell in the hypervisors are recorded in this log. Pretty useful artifact. And then comes hostd.log. So this is the host agent log. So that runs in the ESXi hypervisor. This records any connection attempts against the ESXi hypervisors. That includes SSH, web API calls, or web interface connections. Another useful artifact, you can even see the user agents in the logs. If a threat actor tries to do a time stomping, right, when they try to change the timestamp details, vmk-warning.log will record the details. All the ESXi hypervisors runs in an in-memory file system. So what it means, whenever a ESXi gets reboot, the logs will also get reinitialized. So more chances that you may miss the logs. So at that time, this scratch partition is going to be our savior. So this specific partition is a persistent storage. So it's by default like 4 GB in size, which can be expanded. So this is created while the installation of ESXi. So this will record all the historical logs, no matter what, whether you reboot the ESXi or not. So this is the savior for the incident response team. And then you can leverage this specific query, and you can list out what type of files are accessed, modified in the ESXi host. So when you know the incident timeline, pretty much you can leverage this script, and you can list out the files modified by threat actors. Now let's move to the next section, another sophisticated technique, how threat actors abuse VIX API to perform persistent activities on the targeted guest VMs. So we observed UNC 3886 threat actors. They were using this technique against the guest virtual machines. So whenever you create a virtual machine, right, you would have noticed installing VMware tools in it. So that's mainly used in order to copy files from host to guest or to copy and paste files between virtual machines. But this tool is not only meant for that. the hypervisors can also connect the guest virtual machines through this tool through VIX API. So the administrators can create scripts, and they can leverage VIX API libraries, and they can connect guest virtual machines and perform various methods. The beauty of VIX API is even if the guest virtual machine is contained by your EDR solution, or if the networking ports are disabled, still the hypervisors can connect the guest virtual machines. And through VIX API, you can do various operations. So like listing the registry file or initiating a file transfer from guest VMs. You can start a program. You can delete a file. You can install a specific binary. You can do various methods through VIX API. So I'm listing out an example where I'm trying to push Mimikatz binary on the targeted guest virtual machines, and I'm trying to extract the logon credentials from the virtual machine. So in order to achieve this attack technique, you definitely need an admin permissions in ESXi, and then the VIX API needs to be authenticated with the guest virtual machine. So you need the VM credentials. However, if the VM tools are not patched, someone can exploit authentication bypass vulnerabilities. So a lot of organizations, they don't patch VMware tools regularly that's running in the VMs. UNC 3886 actors, they exploited CVE 2023-20867. So that's an authentication bypass vulnerability. They were able to do various methods without authenticating the guest VM. This is one among the stealthy techniques we have observed in the VMware ecosystem. Now let's talk about how to detect it, right? So most of the organizations will monitor the guest virtual machines, which can be Windows or Unix flavors. So in this example, I've listed out Windows logs. So whenever a hypervisor connects the guest virtual machine, there is a 4624 event ID, Windows event ID recorded. So that's a logon type 4. And as well as if you have a EDR or a sysmon utility, you can also see a specific event created for the service vmtool st.exe. So in the previous example, I was pushing Mimikatz through PowerCLI. So that's why you can see a child process created, PowerShell, for the vmtool st.exe. And in the ESXi side, all the guest operation methods are recorded. So that's recorded in a file called vmware.log. But you may not see the payload details in it. You can only see like list process or initiate file transfer from guest, those types of event, but no payloads in it. If you really need the details of the guest operation method, then you may need to enable debugging in the guest virtual machine for the service vmsvc.exe. So once you enable debugging, you can see the details now. So in this example, I'm showing you starting a program in a guest VM. So you can see details like the PowerShell and the encoded process parameters recorded in this specific log in the guest VM. Another example where I'm trying to initiate a file transfer from guest VM to perform a data exfiltration, for example, right? So this is also recorded, what type of files are moved from guest VMs, as well as like who did that. If you notice in all these logs, you can see an opcode like 188 as well as 185. So that's the unique mapping of guest operation methods. So I'm giving you a sample like the opcodes mapped to the guest operation methods. Whenever you're going to monitor this log in the SIM side, you may need to do some normalization where you need to map the opcode versus the guest operation methods. Enabling debugging predominantly generates humongous of log, and that's a bit noisy. Let's move to the next attack technique, how threat actors target vCenter in order to maintain a persistent access in the ESXi host. So VMware vCenter is a management server predominantly used to manage multiple ESXi hosts. When a ESXi host is integrated with vCenter, vCenter will have admin permissions over the ESXi host. So now threat actors will target vCenter so that they can maintain the same access over the ESXi. When an ESXi is integrated with vCenter, a specific service account is created. It's called VPX user. So this service account is created in ESXi host, and that has admin permissions. Interestingly, the VPX user service account passwords are also stored in vCenter. So it will be stored in an encrypted format. The decryption key is also stored in the vCenter in a file called simkey.dat. So every time, vCenter will retrieve the credential, decrypt it, and then they connect the ESXi host. So this specific service account credential, the password reset happens every 30 days once. VMware is not recommending to reset it manually, okay? So another example of how I extracted VPX user account credential from vCenter. As a first step, so you can access file called vcdb.properties. So this will give you details about the PostgreSQL database. And then you can connect the PostgreSQL database. You can retrieve the encrypted password, leverage the decryption key from simkey.dat. With all these details, you can access some public decryption tools, and you can decrypt the password. Now, with these credentials, you can log into the ESXi host and maintain the administrator privileges. It's pretty hard for SOC team to differentiate whether it is a vCenter activity or this is a threat actor activity, because this service account is meant to be used only by vCenter. However, SOC team can monitor ESXi auth.log. So that will record all the VPX user account activities. And you can correlate based on source IPs. And if you see any source IPs other than the vCenter IP ranges, then that can be a good indicator. So by default, PostgreSQL logs are enabled. In the default setting, the SQL statements executed against the database are not recorded. If you really need that, you may need to tweak PostgreSQL.conf file, and you may need to add a parameter under a log statement with a value all. So this will start recording all the SQL statements executed against the database. So if a threat actor tries to retrieve the credentials from the database, that will also be recorded in this log. Again, this generates humongous of log and a bit noisy. In addition to the PostgreSQL logs, you can also monitor these logs recorded in the vCenter. You can also leverage these logs for investigation purpose. Let's move to the last attack technique, how threat actors run persistent backdoors in ESXi host through WIB files. So WIB stands for vSphere installation bundle. So that's a collection of files packaged into a single archive file used for distribution. Typically, ESXi hosts are upgraded or patched through WIB files. WIB contains three important components. One is the actual payload, and then the descriptor file. So that denotes content, what is there in it. And the third file is called signature file. So that's a digital signature. So that helps us to identify the integrity of the WIB file. So each WIB comes with an acceptance level. So that denotes who created the WIB, as well as what level of testings are done in it. For example, like VMware certified WIBs. So these WIBs are created and tested by VMware, right? If it is a VMware accepted WIBs, these WIBs are created by the partners, but approved by VMware. The third one is partner supported WIBs. So these are created and tested by VMware partners. The last one is a community supported WIBs. These WIBs are created by any individuals. Even the threat actor malicious WIBs are denoted as a community supported WIBs. In the default configuration in the ESXi, partner supported WIBs are the minimum acceptance level. But at any given time, with an administrator permission, someone can change the minimum acceptance level. As I referred earlier, ESXi operates in an in-memory file system. So what it means, not all the installations persist after rebooting the ESXi host. However, if the installations are through WIB files, then predominantly that can persist. So threat actors can package their backdoors or malicious files as a WIB file, and they can install it. Mandiant has identified various malicious WIB in the compromised ESXi host. And one among them is a virtual py, which is a backdoor written in a Python library. So as I referred earlier, partner-supported WIBs are the default minimum acceptance level. So in this default setting, the community-supported WIBs cannot be installed. But however, if a threat actor has administrator permission, they can change the acceptance level and they can install the malicious WIB. Not only that, VMware is also offering you a forceful installation method. So through adding a parameter --force, you can install any types of WIBs. So now threat actors can also use the same method. They can abuse the feature. They can install any types of WIBs. Defenders, you can query your ESXi hypervisors, and you can list out all the installed webs, their acceptance level, as well as the signature verification status. And if you really wanted to query all your ESXi host at a large scale, then you can leverage this specific script issued by VMware team, so through which you can hunt for unsigned webs that are installed in the environment. So we talked about various attack techniques. Now let's talk about some rapid remediation efforts when you see some suspicious activities with the ESXi host. So as a first step, disable SSH and shell access in ESXi and vCenter whenever you observe suspicious activities in it. And then there is a firewall capabilities offered by VMware in the ESXi. Try to create rules, restrict access, and allow only approved IP ranges to connect ESXi and vCenter. That's a very important step we need to do. And then if an ESXi is integrated with Active Directory, remove it from AD. And try to create local accounts and maintain a unique, strong passwords in it. If in case you have a PAM solution, that's the best method where you can access the VMware components through the PAM solutions. Isolate the management interfaces of all the VMware components into a restricted VLAN. We have seen organizations that disable SSH in the ESXi host, but still threat actors can enable it on by just making a web API calls, because the web interface is enabled by default. So to avoid that, you can enable lockdown mode. When you have a lockdown mode enabled, pretty much you are restricting access to ESXi only from vCenter. Very, very important control. I strongly recommend you to enable this control in all your ESXi hosts. So there are two lockdown modes. The normal lockdown mode, you're restricting access to ESXi only from the console as well as through vCenter. If you want a stringent control, you can enable strict lockdown mode. So now we have restricted access to ESXi only from vCenter. The next important step you need to do is enable MFA. So enforce and enable MFA and make sure your administrators perform multi-factor authentication when they need to connect vCenters. So vCenter 8.0 update 2 onwards, you can integrate with Entra ID as well as Okta, and they can perform multi-factor authentication. The earlier versions, they can pretty much integrate with on-prem ADFS solutions, so that through ADFS you can integrate with third-party MFA solutions and they can perform MFA. Let's talk about how to restrict malicious web execution. Enable UEFI secure boot. So this will restrict loading of any unsigned web files during the booting process. Not only that, this will also prevent if someone changes the minimum acceptance level, as well as if someone tries to forcefully install the malicious webs or any types of webs. So let's talk about how to restrict the non-web binary. When I say non-web binary, they are the shell scripts. Not only that, the scripts that comes in a ELF format. Typically, ransomware binaries are in ELF format. If you enable exec install only setting through kernel level, then pretty much in order to apply the change, you may need to reboot the ESXi host. And once the changes are applied, that will restrict execution of any scripts. But however, Python binaries are allowed to be executed in the ESXi host. So if a malicious code written in Python or if ransomware written in Python, I seldom see ransomware in Python, but in those scenarios, they can circumvent this control. So that's something that we need to be aware of. All right, so we explored intricate attack techniques used by threat actors targeting VMware ecosystem. And we also discussed some of the investigation steps as well as some rapid remediation. We are leaving here not with a sense of fear, but with a renewed commitment to proactively defend our hypervisors, so that the scenario which I've briefed in the beginning remains hypothetical, not in our reality. Thanks a lot for listening to my talk. Appreciate your time. Thank you.